So back to the rules of modeling, we were talking about what are the rules that we would like to use for modeling. These are, like, I would say, these are rules of thumb, okay, or more like practitioner's rules in a way, okay. So the number one thing that you should understand is there are different ways, there are different ways to model a problem, model any optimization problem. There are many ways, there are multiple ways to model any optimization problem, okay. So when you have multiple ways to model any optimization problem, it is already going to create an issue for you, okay. Models of the same optimization problem, when you have models of the same optimization problem, can pose very different model solving challenges, okay. So what we are saying here is that if you have different ways of modeling, the ways of modeling, you just don't want to model the problem, okay, you just don't want to model the optimization problem, you actually want to solve it. So depending upon how you model it, you will end up resulting in having different challenges in solving the problem, okay. So this is one fact that you need to understand. Then the following rules of thumb, these are not really official rules, but these are guidelines. Thumbs should help a modeler, okay. Modeler, who is a modeler? An individual, right? The individual who is doing the model is the modeler, should help a modeler to avoid some model solving pitfalls, okay. So there are some issues in the model solving. When you come to solving a model, you can build a model, but sometimes you will end up building a model that will be very tough to solve, okay. So what you want to do is you want to avoid such scenario where you end up building a model that is difficult to solve. So the aim is to avoid building models that are difficult to solve, okay. And remember, to difficult to solve means computationally. Why? You are using a computer to actually solve the model. The modeling is done by hand, the solution is done by the computer. So if you build a model that is difficult to solve computationally, then you want to avoid such kind of modeling exercises. So these rules of thumbs are designed to avoid building such models. So the first rule, the major rule in that regard is rule 1, okay. First rule is keep it simple, okay. I would go and say this is part of the KISS principle, keep it simple and stupid principle, but it's keep it simple, okay. Keep it simple means, okay, use functions that you recognize from calculus, okay, and in those use the simplest ones, okay. So as much as possible try to use the functions that you recognize from calculus. The advantage of the calculus allows you to do differentiation and integration in a way that actually helps you to use the gradient method of solving the problem, okay. And even in the calculus functions that you use, ensure that you use the simplest ones, okay. So in particular use linear functions whenever possible use linear functions whenever possible because they are the simplest. Okay. So, for example, if you write a function, okay, x1 plus x2 divided by x3 plus x4, okay, is less than or equal to 5, this could be is computationally hard or because of this quotient approach, the computer might take longer time or longer, it will be not very easy to solve using a software. You can write the same as, okay, x1 plus x2 is less than or equal to 5 times x3 plus x4. Okay. If you write it like this, then this is a linear form, easy to solve computationally. Okay. So, the first one is keep it simple, which means you use functions that you recognize from calculus, such these kind of functions, and in those functions use the simplest one. If you have a fraction like this, okay, or if you have a quotient version like this, convert it into a simpler linear function. So, this is the process, we can call it as simplify to linear. As much as possible, try to use linear functions wherever you can. Okay. Then the second rule of modeling, okay, there are 4 rules. The second part of it is rule 2. I will call it as keep it lean. The first one is keep it clean, second one is keep it lean. Okay. So, which means constraints that can be removed without affecting constraints that can be removed without affecting the solutions to the model should be removed. Okay. So, for example, an example of this would be, if you have a constraint called x1 plus x2 is less than or equal to 10, and let us say you have a constraint called 3x1 plus 3x2 is less than or equal to 30. Okay. If you think about it, one and same constraint. Okay. Though these constraints are one and the same, writing the constraint 2 times, so it can cause difficulty with solvers. Okay. If you are using Microsoft Excel or something to solve the problem, then such solvers will have difficulty when you see these kind of constraints which are 2 times. So, second part of the second rule is keep it lean, which means constraints that can be removed without affecting the solutions of the model should be removed. If you remove one of these constraints, so for this example, if you are saying that I am going to eliminate this constraint as part of this, okay, I do not want that constraint because it is a scaled constraint of the other one, it is not going to affect your final solution because a set of values. So, in this case, okay, if I call this as 1 and this as 2, okay, any set of values, so any set of values that satisfy 1 will also satisfy 2. Okay. So, there is no need to put duplicate constraints or such kind of constraints that are duplicated in this regard, right. So, most of the solvers would not like you to do these kind of things. Then the third rule, rule 3, okay, rule 3 is keep it compact. Okay. So, keep it compact means what you are saying is consolidate constraints whenever it is possible. Say whenever you want, whenever it is possible for you to consolidate the constraints, then do that. Okay. So for example is that if you have a constraint that says x1 times x2 times x3, okay, is less than or equal to 10, okay, and you have another constraint that says minus of x1 times x2 times x3 is less than or equal to minus 5, okay, then you can consolidate this by saying is that 5 less than or equal to x1 times x2 times x3 less than or equal to 10. Okay, you can do a consolidation. So this is a consolidated constraint. Okay, so when you consolidate a constraint, then that becomes easy for the solver to do this. Okay, so solvers work faster when constraints are consolidated. Okay. So this is an advantage that you will have if you try to do this. So whenever you can do, whenever you say keep it compact, that means you are consolidating the constraints whenever it is possible for you. Okay. All right. Then comes the third rule of modeling, rules of modeling 3. Okay. The rule 4, the fourth rule. We have gone through 3 rules so far. The fourth rule is keep it continuous. Continuous. Okay. So it is better to use continuous variables if possible, or instead of if possible, whenever possible. Okay. Whenever possible. Okay. It is better to use continuous variables whenever possible, okay, over those variables that are constrained to have integer values or a finite set of values. Okay. So what you are trying to hear is, it is as much as possible, whenever it is doable, use continuous variables or the value of the variable. So if you say that a variable x x2, if you say 2 less than or equal to x less than or equal to 5, okay, that means all values between 2 and 5, okay, and there could be a scenario where you can say an x5 where the values can be of 2, 3, 4, 8, 10, something like this. Then it is always better to use a scenario of a continuous variable than a discrete or a set of variables that are integer set of values or a finite set of values. Okay. And why? The question is, why do we use this rule? The answer is, optimization solvers, the computer programs, okay, which they solve the models. Okay. The optimization solvers which require the computer, okay, work much faster, okay, with continuous variables. Okay. They work much faster with continuous variables than discrete variables. Okay. Why? Continuous variables, they allow for the usage of calculus techniques. Okay. So since the continuous variables allow you to use calculate techniques or techniques of gradient or those such kind of things. The optimization solvers will work much faster in the realm of continuous variables than the discrete variables. So we have seen there are 4 rules to this. Okay. So if you think about the rules, the first one is, rule 1 is keep it simple. Okay. Keep it simple means as much as possible keep the function simple, whichever it can be used. So it's like use simple calculus functions. Okay. Linear whenever possible. Okay. Whenever possible. Number 2 was keep it lean. Lean. What we said is, okay, eliminate duplicate constraints or constraints that can be reduced. Okay, or duplicate constraints in this case I am actually referring to is eliminate the duplicate constraints means constraints that can be reduced. Then the third one we talked about, it was keep it compact. Okay. So in keep it compact, what we did is consolidate constraints whenever is possible. And then the fourth rule what we talked about is keep it continuous. Okay. So whenever possible use continuous values for use continuous variables or use real variables. Let's put it as real variables. Okay. Variables over discrete variables. Okay. So if you think about it, this whole thing what we have covered in the class so far today is the main 3 aspects of optimization, and we talked about the components of optimizations as the variables, the constraints and the objective function, and we took a simple example, in the simple example of moving from a college student moving from one city to another. And in that process what we did is we studied the variables, constraints and objective function using these examples, and how do we choose a variable, and in this case we choose a binary variable 0 1 and yes and no because this is the easiest one to understand the modeling aspects. Okay. You will probably ask me the question now, why did you not choose a continuous variable? The reason is I can always say that I can write it here now, easy to learn modeling using discrete variables. Okay. We will try to work on a continuous variable example later down the road, but it's easy to teach this kind of a problem, so that's why we used this one. Then we talked about what are the different type of constraints and how you iteratively create constraints to reach what you actually want at the end of the day. Okay. So we went through different type of constraints, and finally what we said is that, okay, we finally got a scenario, all the constraints together, where the aim of it is all constraints together results in a round trip with each city visited only once. Okay. So then once we talked about how the constraints are created, then we discussed what's an objective function, and an objective function we had a cost one and decision variable one, and the decision variable and the cost gets multiplied together and summed across, and since we wanted to minimize the total cost of the trip, so we used a minimization function, and we saw why it is called as an objective function, and that aspects we discussed this. And then we went into the 4 rules of modeling, which the main aim is to ensure that the model that you are building is not going to be something that is very tough to solve. And then the first rule was so we went to 4 different rules of this, and the 4 different rules came down to the rule number 1 being as keep it simple, which means use simple calculus functions, and whenever you use calculus functions, in that also you try to use linear functions whenever possible, because linear functions are easy, and you can also, if you use calculus functions, then it's very easy because you can use gradient. Okay, gradient function in that regard, which is very fast in calculations. So then keep it lean means whenever you have duplicate constraints, eliminate them, remove such duplicate constraints so that your optimization model is lean. And keep it compact, which means consolidate constraints. So whenever you have additional constraints that you think you can write it in one single sentence, then consolidate them accordingly, and then keep it continuous. So whenever you possible, instead of using discrete values, use real values for the variables, and once you use real values, then you can, the major advantage is that you can use calculus, work faster, because it allows for the usage of calculus techniques, which includes gradient methods and those kind of stuff. So I hope that by going through this whole process, this is again not an optimization class. This is just a very quick capsule form of optimization, hoping to make you guys understand different aspects of optimization. For you to become an expert in optimization, there is no other way other than work on different optimization problems, take real life problems, model them accordingly, and keep on modeling so that you understand the language of modeling. Try to use these 4 rules of modeling, the rule of thumbs of the modeling, so that you come up with really good models. And once you have these models ready, then try to use various model solution techniques. If it's a linear programming, then you can use an LP problem or an LP solver that comes with Excel, Microsoft Excel solver. And then for non-linear or complicated ones, there are other things like OPL Studio, Optimization Programming Language Studio, which is a product of IBM, stuff like that. So there are multiple options available for you in that regard, but that is outside the realm of this course. The aim of this course is to introduce you to the basics of optimization. Maybe in the due time process, we will try to work one more problem so that you understand how optimization happens. Maybe we will try to see a problem where different variables are considered at the same time, and how do we optimize it, as a small example. And then from there we will move into other aspects, how some of the techniques, because as of now we only talked about modeling and rules of modeling and some of the rules that we should think about optimization. We did not talk about model solving at all. So what are some of the model solving techniques available? What are some of the algorithms that are available for people who want to do optimization? That will be part of the coming lectures. In the meantime, continue to read the assigned textbooks, and in that process hopefully you will gain an interest in this, and all these techniques that we learn in the class, you will end up using it in your real life to make a manufacturing system sustainable, which is a goal of this course. Thank you very much.